Hello everyone. With this diagram, we'll try to learn how concentration of the urine occurs. For the concentration of urine, the things which are important are the structure of the nephron itself. Second one is there is a concentration gradient across the loop of the Henle, that is, it ranges from 300 milliosmoles to 1200 milliosmoles at the tip of the loop of the Henle. And the third one is permeability nature of the loop of Henle. The descending loop of Henle is permeable to water but impermeable to solutes. So that is how when the filtrate reaches into the loop of Henle, the water is going to move out, and at the tip of loop of Henle it becomes 1200 milliosmoles per liter. And it is also because the permeability nature of the ascending loop of Henle, where it is highly permeable for the solutes but impermeable for water. Permeable it is because the presence of sodium, potassium and 2 chloride channel, which is going to reabsorb a lot of sodium, and by the time the fluid reaches to the uh, DCT, the osmolality reaches up to 300 milliosmoles per liter. And when it reaches the collecting duct, again because of the osmotic gradient, water is going to continuously move, and by the time it reaches the uh, collecting duct, tip of the collecting duct, the concentration reaches to 1200 milliosmoles per liter. And uh, so the reabsorption of the sodium, which is also very responsible for the maintenance of concentration gradient, the sodium thus reabsorbed, it is going to create the concentration gradient as the sodium percolates down till the tip of the loop of the Henle. And also the concentration gradient is also maintained by the urea. Once urea is reabsorbed here, so it is going to be reabsorbed into the loop of Henle, even in the descending and as well as ascending. And again, when it comes back to the collecting duct, it is reabsorbed, again it is recirculated. So that is how urea also plays an important role in the maintenance of the osmotic gradient. And also another important thing is the vasa recta, so which is the vascular structure uh, where the flow of the vasa recta is just opposite of that of loop of Henle. The blood with 300 milliosmolality enters here. Because of the higher concentration sodium in the medullary interstitia, it enters, whereas water is going to move by the when it reaches the tip, the concentration in the vasa recta reaches up to 1200 milliosmoles. And when it ascends up, the opposite thing is going to happen, that is the sodium is lost, and the water is going to come inside. And when it leaves, the blood is concentration is around 325 milliosmoles per liter. And it all depends, the concentration of the urine depends on the presence of ADH. So when in presence of ADH, a lot of water is reabsorbed, and it is going to excrete the concentrated urine. When the ADH concentration is low, it is going to excrete dilute urine.